Hey everyone, how's it going? I'm going to be doing this as one single take because I cannot be bothered to do any sort of video editing. I have 3 other YouTube channels that I have to do a lot of videos for, so we're just going to do this all in one go. So I want to build something like this, but DIY. I know, right? Really? This? DIY? Yeah, well, you know what, whatever. We're doing an experiment. So the pad controller, the software that is running on the Akai MPC is a little. It's great for a lot of things, but it's. I wish it had some improvements, and there's quite literally zero chance those improvements are going to be added. So this kind of prompted me to say, okay, well, what if we go and make our own pad controller? Well, okay, well, here I am. I've got a packet that came in today, and no, this isn't the packet, this is the thing that was in the packet. This is a really cool material called Velostat. Essentially, it's a conductive film, which is becoming more and more resistive the more you squeeze it, or the more force you exert on it, which is coincidentally the way these pad controllers handle their pads. So all of these, 16 pads, 4x4, the harder you press on them, the louder the sample is going to be played. So the way they achieve it is by the use of this material. So I kind of wired it up to do a little test, and it honestly blew my mind as to how easy it was to get this up and running. So all I have is just the multimeter measuring resistance, and one lead, one terminal is connected to one set of contacts, another terminal is connected to the opposite set of contacts, and you can see that this is a pretty simple setup. We've got a whole bunch of connections on the left, a whole bunch of connections on the right. They have they kind of share common space, but they do not touch each other in the middle. And even if I say touch it with my finger, you can see it doesn't even change a bit on the resistance level. If I maybe tone down the no, not even if I tone down the sensitivity, it doesn't really detect it. It does technically detect it a little bit. I have the multimeter, or excuse me, the oscilloscope connected also to the terminals of the multimeter, so that I can measure the voltage, because that's how the multimeter measures resistance. And you can see that if I touch it with my bare finger, just barely, very barely, the resistance of my finger allows just a few electrons to jump over between the contact, and you can see the voltage goes down just slightly, right? As a matter of fact, if my finger is a little bit more, say, wet or sweaty, you can see that, yeah, just a bit, it can kind of detect it, which is good enough for capacitive touch, but, we want to have variable resistances. So if I use this little strip of Velostat material, you can see that as I'm pressing down, it goes almost all the way down. I'm sure there's a particular sensitivity curve. You can see that the multimeter is using about, looks like what, about 3 volts, because it says, I'm sure that the professionals already know this, 1 volt is 1 box, so there's about 3 boxes here, so it looks like the multimeter is outputting 3 volts in order to measure the resistance. And if I can wiggle it, there we go. When I'm pressing down, you can see the resistance cause the voltage level to drop. So I am absolutely blown as to how easy it was to set this little experiment up, which gives me some hope in setting up some sort of a basic pad controller arrangement for, some sort of a DIY pad controller. Maybe, who knows, maybe this project will just be an open source project. I don't know. I've got too many other projects going on at the same time to really worry about commercializing stuff. So, cool. can see that even the multimeter is showing us proper resistance. This is super cool. So this little piece of circuit board, I had essentially used the fiber laser to cut out. I have a fiber laser which I use for engraving panels, tools, doing some favors. Yeah, doing some tests. Some of my recent panel work is right here, which a gentleman off of Facebook has requested to engrave a couple panels. So I just simply use this tool in order to engrave this this pattern, and it actually came out quite well. I'm quite surprised. So, cool. I mean, that's I would say that's a success for the first experiment. So the idea is to pair this up with the Raspberry Pi, which has been out of stock and scalped to no end and completely overpriced for the past 2 years, thanks to the chip shortage. And the Raspberry Pi Foundation says that it's going to equalize, and they've been saying that for the past 2 years. So I don't know. Well, we'll work with this for now, and if there's any alternatives, which technically it doesn't really matter if it's a Raspberry Pi or Banana Pi or whatever other Pi there might be, they technically should be universally the same because they're running on Linux. So the idea is to pair up some sort of a Linux computer with an array. Maybe instead of going 4x4, we go 8x8. Right? Differentiate between what is already out there by giving us more pads to play with. This is the one thing that this device offers. It offers 4 different banks. So you can switch between those 4 banks, and then these pads can be assigned different sounds. You have to rapidly switch between banks to play different sounds on the pads. So maybe instead of just offering banks and sticking to the 4x4, maybe we can make like, I don't know, 8x8, for example. So more pads, more sounds to play with, more variety. You don't have to switch between banks and none of that nonsense. Which, again, it's not like that's a huge problem. Switching between banks, you just train yourself to do it fast and you'll be good. But this is more interesting. This stuff is way more interesting to play around with. So, cool. Here's my low-effort first video for this little experiment. Don't mind the desk. There's like 4 other projects scattered across, so I can't be bothered to put it all away. Otherwise, I'm never going to finish it. Okay, cool. I'll see you guys in the next episode with whatever progress I make in the future in this.